So, I'm starting out with what is a polynomial. So this week you guys are introduced to polynomials, and we're going to be looking at polynomials for the next 3 weeks. So you're going to be like learning how to do stuff with them, like add and subtract, multiply this week. Then you will learn factoring of polynomials next week. And then week 6, you'll be learning how to solve equations with polynomials. So we're going to have 3 weeks of polynomials, and then you'll have an exam week 6, which will basically cover polynomials. So like your week 3 exam is covering linear equations, and so this will, your next exam will be basically polynomials. So it's good to understand what a polynomial is, so that way you have an understanding of what you're going to be doing, and you know the difference between this and when we consider like linear equations. So I always like to go into some history, just to kind of give you some insight into where these names come from and everything. So I did some research into the word polynomial, and so it was actually first used in English in 1674. And so polynomials were studied before then, we just didn't really have a word for them until then. And it comes from Greek. So poly means many, and then nominal or nominal, I guess, means terms or many terms. So that's another source that I found. I've always thought that the nomial part came from the Latin word nomen, which means named, because in that first quote it says many named. So I don't know which is more accurate, whether the nomial part comes from Latin or if it comes from Greek, but either way basically means you have many things. So that's what we've got with a polynomial. So let's look at the mathematical definition of a polynomial. So we've got a naught. So a with a 0 as a subscript is pronounced naught. A naught, a1, and so on to an be real numbers, and then let n be a non-negative integer. So that just means positive. A polynomial in X is an expression of the form, and then we've got this big long thing. Essentially, we've got this thing where you've got terms added together, and these terms have exponents, and they're written from the highest to the lowest exponent, and then the a's are the coefficients. And so n cannot equal 0, so it's just we don't have a 0 coefficient for that highest term. So each thing separated by a plus is the term of a polynomial. So this is where you see it's many terms for that definition. Each term is a form where it's a number times your variable to some exponent. So the number in front is the coefficient, and then that exponent is called the degree. And then when you have the highest term, that is called the leading coefficient in front of that, because it leads the rest of the polynomial. And then the lowest one, where you have a number without a variable, is called the constant term. So trying to translate this mathematical thing you're looking at into regular words, essentially a polynomial is you can have one term, or you can have a sum or difference of terms, and they're all in a form number times x to an exponent. So you can have a polynomial that's one term. You can have 2 terms, you can have 3 terms, you can have an infinite number of terms of a polynomial. What is special about a polynomial is that your variable is never in the denominator of a fraction. It's never in like a square root. It's never inside an absolute value. Your variable is always just by itself or has an exponent on it. And all of the exponents are positive whole numbers. So you don't have any decimal exponents. There are no fraction exponents. That's what makes a polynomial. So an example of a polynomial would be something like this: 3x squared plus 2x minus 5. We have 3 terms there, and then we've just got variables with exponents on it. So that is a polynomial. So there's a lot of definitions that come with polynomials. So there's standard form, and that just means you write the exponents from highest to lowest. We have the degree of a term, that's equal to the exponent. So on this example, that first term here is degree 2, because the exponent's 2. This would be considered degree 1, because if you don't have an exponent, you can always put a 1 there. And then the last term is degree 0, because there's no x at all. So that's the degree of a term. And then the degree of the entire polynomial is equal to the highest exponent. So this that I have here is a degree 2 polynomial, because that's the highest exponent. The term with the highest degree is called the leading term. Oops. So the 3x squared is the leading term. The coefficient of the term is the leading coefficient. So 3 is considered the leading coefficient here, because it's a number in front of the highest term. And then on the right here, if you have a polynomial of one term, it's called a monomial, because the word that mono usually means one. So like a monocle has one eyeglass. So that means one. If there are two terms, it's called a binomial, and bi means two, because like a bicycle has two wheels. And then 3 terms is called a trinomial, tri meaning 3, like a tricycle with 3 wheels. And then we don't have names for anything other than that. So anything higher than 3 terms we just call a polynomial. But there are special names for 1, 2, and 3 terms. So this is the terminology that we're going to be using. So having these written down somewhere, especially if you've got a problem and it's asking you to find some of these things, you kind of need to know what does it mean. Are there any questions so far? Okay. So let's move on to some examples. So we're just going to be looking at what things are polynomials, learning the terminology, definitions, that kind of thing. So I've got a polynomial here, 10 minus 8a minus a cubed plus 2a squared plus a to the 5th. So the first step is to write the polynomial in descending order. That just means you write it from the highest to the lowest exponent. Now, I recommend before you do this that every subtraction you write as adding a negative. That's something that I've suggested from the beginning of the class when you're solving and when we're simplifying expressions. Same thing here. It will make things easier for you. So add all subtraction as adding a negative. So I'm going to first rewrite that. So instead of minus 8a, it's going to be plus a negative 8a. Then I have plus a negative a cubed plus 2a squared, and then plus a to the 5th. So now when we want to write it in descending order, we go from highest to lowest. So the highest exponent is a to the 5th. So I'm going to put a to the 5th first. And if it helps, you can kind of cross that out so you know what's left. We start counting down. We don't have a to the 4th, but we have a to the 3. So that's going to be the next one. So I'm going to write, there's a plus negative a to the 3, so that's going to be a negative a to the 3. Then next counting down gives me the 2a squared, so that's plus 2a squared. Then you always do the a, and then the number goes last. So it's going to be a minus 8a, and then plus 10. And so that is now, this is called standard form because it's going from highest to lowest. And the reason why I suggest that you write your polynomial first with adding a negative is so that you make sure you have your negatives in the right place. So that, you know, sometimes people might write plus 8a, not realize that that minus 8a, the minus is going with it, and so it's really a minus 8a. So it just goes wherever you place it. So when it says write the polynomial in descending order, what it's asking you to do is to put it in standard form, and you're going from the highest to the lowest. Then step 2, or question 2 here, is to identify the leading coefficient. So the leading coefficient is the number in front of the highest term. So that, where we'd be looking at this first term here, that's the leading term. And if there's no number in front of there, the leading coefficient is 1, because you can always put a 1 in front of the variable. So that can be a 1 a to the 5th. So our leading coefficient is 1. Then question 3 here says identify the degree of the polynomial. So the degree of the polynomial is the highest exponent. So again, you look at that leading term and you read that exponent, which is 5, so that is the degree of the polynomial. It is 5. And so we'll often call this will be a 5th degree polynomial. And that just means what is your highest exponent. So a 2nd degree means your highest exponent is 2. 1st degree, your highest exponent is 1. So you're just basically looking at the highest exponent, and that's what we care about. Are there any questions here? All right, so next one, we're going to do something the same. This time I want you guys to kind of be interactive with this. And so, you know, you can do this on your paper. So we want to write the polynomial in descending order. So you're welcome to type it into the chat. When you're typing things into, like, when they have exponents, the caret symbol is how we do an exponent. So if you were typing, you would write like 7x, you'd put in that caret symbol, and then you'd put the 2 to indicate that's your exponent. So we're doing the same thing here. We've got 6 plus 7x squared minus 7x to the 5th plus 9x, and we want to write it with the highest exponent first down to the lowest. So go ahead and you can do that on your paper or wherever you're taking notes, and then you can type your answer into the chat. So I'll just give a little bit of time for that. The technical term caret, I think it's actually spelled differently, but yes. I'm gonna just do a quick Google search. Well, I guess sometimes it's called a hat. I've always called it a caret. That's how I've seen it. Yeah, this also says it's called a caret. Yeah, shift 6. Yeah, so it's actually spelled this way, but sometimes it's called the hat. But the technical term is caret, but it's not spelled like like the vegetable. And yeah, it's 6 or shift 6. So it's just the number, and that works in Connect Math as well to get to exponents. You just hit shift 6 and then it'll put you in the exponent. And that works in like Desmos when you're graphing and stuff like that as well. So it's okay. So we've got negative 7x to the 5th. Okay, negative 7x to the 5th. That is the highest. Then we've got plus 7x squared. I'm assuming that's just a typo in the chat. And then we have the plus 9, plus 9x, and then plus 6. So that is standard form. And whenever you do this stuff like on a quiz or Connect Math, always double check your numbers because it's really easy to accidentally hit the wrong number when you're typing these things. So I've done it myself. I'll type the wrong number. So, or it's sometimes you write down the wrong numbers. So that's standard form. That's from the highest to the lowest. So step 2 is the leading coefficient. So that is the number in front of the highest term. So that's going to be negative 7, because that is what we've got right in front of that x to the 5th. And then 3 is the degree of the polynomial, so that is the highest exponent. And so you just look at your exponents, and the highest one is 5. So pretty straightforward. Are there any questions? All right. So this is actually my last example. So like I said at the beginning, this is a quick one. You're focusing mostly on the definitions and everything here. But here we're going to be categorizing each expression as a monomial, binomial, or trinomial. So the monomial has 1 term, the binomial is 2 terms, and the trinomial is 3 terms. And I think there might be a delay for some people here. Oops. But yes, so standard form for the example that we did going from highest to lowest is negative 7x to the 5th plus 7x squared plus 9x plus 6. So it's very easy to make typos there, forget a plus sign or something. And that's why it's important to turn in your work that you do on paper after you take like a quiz. So that way, if there is like, if you accidentally typed the wrong number or you left off a plus sign or something like that, we can give points for that. So going back to here, so we're going to categorize each expression as a monomial, a binomial, or a trinomial. And so when you're doing this, you're looking for things that are separated by pluses and minuses, because terms are separated by those plus and minuses. And if you think of the minus as adding a negative, that just adds another plus. So we're just counting how many terms we have, and then if it fits, it's either monomial, binomial, or trinomial. So the first one here, we've got 1 term and then a second term. They're separated by a plus. We have 10x squared plus 5x. So 2 terms means it's a binomial. And so that's a binomial. It's also called a second degree polynomial because that's second degree is referring to the exponent, not necessarily how many terms you have. And you'll learn later that this is also called a quadratic. It has a second degree, has special names. So anything with an exponent of 2 has a special name of quadratic. The next one underneath it, we've got 7z plus 13z squared minus 15. So this is three terms. That minus 15, that's an adding negative 15. That's the third term there. So three terms makes it a trinomial. Then underneath we have 6x squared. So that's just one term. We don't have any pluses or minuses or that. So that is a monomial, because it's just got one term. And underneath that is 9. That also, it's just a single number. Technically, any number by itself is also called a monomial. So any number by itself is technically a polynomial, though it's silly to refer to it as one because it doesn't have any variables. But technically, it does meet the definition of a polynomial. But generally, we don't call 9 a polynomial. Or even a monomial, we'll just call it a number. But technically, it fits the definition. Underneath that, we have 2y minus y to the fourth. So this has two terms separated by one symbol. So two terms mean it's a binomial. And then underneath that, we also have something with two terms, 7x plus 2, two terms. And if you notice, that is also basically linear, because when we think of things, we solve the linear equations, it would be something like 7x plus 2 equals a number. So linear equations are polynomials, or linear expressions are polynomials. So everything we've done so far up to this week was technically working with polynomials. They were all first degree because they basically just didn't really have an exponent. It's just one x in there. So we're just building on to that, but they are all technically polynomials. Then we've got 2y to the fourth minus 3y plus 1. And so this has three terms, which makes it a trinomial. Now, underneath this, we have multiple variables. We've got negative 32xyz. It doesn't matter that there's more than one variable. It's still one term. It's still a polynomial. So you could have polynomials with different variables. You don't have to have just one variable. So this would be considered a monomial. And then our last one, y to the fourth minus x squared, we've got two terms there. So two terms means it's a binomial. And so just to add in some of that extra information that I've talked about, this one, the 7x plus 2 is linear. So that is something that we've learned. We've talked about linear equations. So if it has, if the highest exponent is 1, it's considered linear. The 9 is also considered a constant because it has no variable by itself. So if there's no variable, it can also be called a constant. And then I mentioned, and we're going to be learning about this next week more, is a quadratic, where it has an exponent of 2. So anything that has a degree of 2, where that highest exponent is 2, is considered quadratic. So quadratic equations could have more than one term. Whoops, I forgot the D in that one. But anything with the highest exponent being 2 is called quadratic. And then these other ones that I didn't label, these aren't anything special. Usually what happens is we focus on learning about linear and quadratic equations, and they're both considered polynomials. So, because those are the ones that we just see more often, so that's why we give them special names. So quadratic means the degree is 2. Constant means the degree is 0 because there's no variable or anything. And then a linear is degree 1. So if we go back to where we were rearranging these from the highest to the lowest, and then we were naming the degree is determining whether you call it constant, linear, or quadratic. But the number of terms is based off of it's a monomial, trinomial, or binomial. So these are, this column is the degree, which gives it that particular name, versus this is the number of terms that gives it the name binomial, trinomial, monomial. So you can have something that has multiple names, and it's just a matter of what are we looking at. Are we looking at the number of terms there are, or are we looking at the degree? So that's why it's important to know the vocabulary, because the words, you may have multiple words that refer to the same type of problem, but they're focused on different properties or different aspects of what you're looking at. Are we looking at the highest exponent, or how many things we have added together? So I would definitely, maybe when you're studying for a quiz or after you go through and you take all your notes, like I would go back through your notes and make a cheat sheet, or like make a definition sheet and go through, or maybe, type it up on a computer so that you can put it in alphabetical order or something like that. But I would definitely, after you've gone through and taken notes, is kind of take all of those definitions and put them together on a single sheet or multiple pages, however long it takes. So that way you have it in one place. And so if you're doing a problem and you don't recognize the word, you can look it up and then you can see in your notes, oh, that's what this was. Are there any questions? Okay, so this was my last example. I did make another one like this, but I think it's pretty straightforward. So the big thing is understanding all the definitions. So after I post this on YouTube and everything like that, what I recommend doing, and I'll email it to you, is, going through and maybe printing off these notes or maybe putting them in a Word document, these definitions. I do, I like handwritten notes for doing the math problems because it's really hard to type mathematics. But for like definitions, I like typed notes because you can use the search function. So that way you can just do like the find function on a Word document and type in the word you're looking for and then find it. So that's what I would do for notes, is I would have like handwritten notes for actually doing the problems, and then maybe typed notes for like definitions, because then you can also just copy and paste from my slides into there. But that's just a suggestion. You guys can take notes any way you want, but flashcards are great for learning the terminology here, because there's going to be a lot of vocabulary that you're going to be learning the next few weeks, and so flashcards could be very, very helpful for that. So that's, in a nutshell, that's what a polynomial is. That's sort of when you're told to like analyze a polynomial, you're usually looking for properties. What is the degree? What is the leading coefficient? You're taking the equation and you're identifying certain parts of it. That's usually what's called analyzing something. So at least this should give you some basis. So now when you're going into the rest of the sections, like learning how to add and subtract these things, you kind of understand the terminology behind it so that you know what you're looking at. Definitely for adding and subtracting and multiplying and dividing. Well, you guys are not going to learn dividing, so that will be in college algebra. But the adding, subtracting, and multiplying of polynomials, write all subtractions as adding a negative. It will really help you so that you don't make as many sign errors. And yeah, I think that's it. So I think that's pretty much all you guys need to know for this week. Other than just the rules of exponents, but that I've got a video all by itself on that, and you've got a homework assignment on that. Are there any questions? All right. I'm hearing nothing. I've seen nothing in the chat, so glad that this was helpful. Yes, and for submitting your work, you can do so screenshots are good for doing the homework screenshot of the grade book. There's like Snip and Sketch, which is usually on most Windows computer. It's an app that you can do to take a screenshot. And then for turning in your quiz work, taking a picture is completely fine, and then just uploading it to Blackboard. Some people email it to themselves and then download it on a computer. But I have a phone app. I use Adobe Scan on my phone, and it basically will take photos and then turn them into a PDF. And I usually do that. And you can even do that with your notes. You can take handwritten notes, turn it into a picture, and then put it into a Word doc or something if you want to take notes that way. Whatever works for you guys. So, all right, well, I'm going to let you guys go and enjoy the rest of your Saturday. Hopefully you have a good weekend, 4th of July weekend. You know, a lot of people usually spend it with family, and now that things are opened up, I know a lot of us probably couldn't do anything last year for the holiday, so I'm sure you guys are looking forward to spending time with family and seeing people. So yeah, I'll let you guys go and enjoy yourselves, and I will talk to you guys later. Take care, everybody. Bye.